continue from here. So you can see the phenylethanol, okay, can be used as a starting material to make phenylethene in a two-step synthesis. Okay, and from what I can see here, okay, you can see it's a ketone. Okay, it's a ketone. R group, another R group is a ketone, and then you are going to change to something, and then that something is going to be changed into alkene. Okay, you can see alkene double bond. Now, to produce something, okay, related to alkene, okay, I know for sure, okay, I know for sure this one must be something related to dehydration, okay, because it's quite limited. Okay, what are the reactions that can give you double bond? Okay, so maybe if I have alcohol, then I can dehydrate. Okay, maybe if I have a halogenalkane, then maybe I can do elimination reaction. Okay, something like that. Okay, that's my thinking process. But I need to think about ketone. There are, for ketone, there's only limited certain reactions involving ketone. So you need to also remember that. I think for the ketone, I think if you look at the previous reaction, okay, for anything that is involving aldehyde or ketone, you have the one reaction which is going to be the reaction with HCN. Okay, HCN or with NaCN. Okay, so this one is called addition elimination reaction. Please take note as well. So again, this is going to be nucleophilic addition reaction. So here, okay, when we look into this, okay, there is one reaction involving ketone, which is going to be, you can react with NaCN with ACN. Okay, you are going to get nitrile. Okay, now that reaction, okay, is not going to be suitable here because you do this reaction in whenever you want to increase the number of carbon. Okay, you can see here number of carbons are the same, so you do not need to increase any carbon over here. So we need to think about other reactions. Okay, very less reactions involving ketone. Yeah, so one thing that I can think of, okay, is going to be when we learn about alcohol. Okay, when we learn about primary alcohol, okay, can be oxidized to it can be oxidized to become aldehyde. Okay, and aldehyde can be further oxidized to become carboxylic acid. Okay, and I also learned that, okay, secondary alcohol, okay, can be oxidized to ketone, and tertiary alcohol cannot be oxidized. Now, so now I have ketone over here. Okay, if secondary alcohol can change into ketone, of course there is a way to change ketone to become secondary alcohol. Okay, so this is going to be, we are going to change, okay, ketone to secondary alcohol, which is going to be we are talking about dehydration. Okay, sorry, it's not dehydration, this is going to be reduction. Okay, we are going to do reduction. Now please remember, when it comes to reduction, okay, it is sometimes, okay, we can have situation like simple reduction, like ketone to become alcohol, or aldehyde become primary alcohol. Okay, you can use any reducing agent. Okay, you can use any reducing agent, but whenever you are trying to reduce carboxylic acid to become primary alcohol, then you need a stronger reducing agent. Okay, please remember that. So the stronger reducing agent is LiAlH4, okay, in dry ether. This is a strong one. Okay, we do not use the NaBH4 here. Okay, please remember this. So this one, okay, we have to use this. But okay, for this and this, you can use both LiAlH4 in dry ether or NaBH4. Okay, LiAlH4, NaBH4. Okay, you can use. So here, when they say identify the regions responsible over here, and before that, okay, when they are asking me to write down the structure, draw the structure. Now they didn't specify what kind of structure, okay, display formula, structure formula. So when they don't specify, anything will do, okay. So even you draw like this also fine, yeah. So when you have this, okay, I know when I do the reduction, what's going to happen, the H is going to come over here, another H will come over here, okay. So when you have that, okay, you are going to have this alcohol over there. So this is going to be a secondary alcohol. Okay, I wrote over there, secondary alcohol. Then after that, okay, you are going to have the step number 2, which is going to be the dehydration. Okay, so anyway, the identify the suitable region for step number 1. Step number 1 is going to be, it's going to be a simple one, secondary ketone to become secondary alcohol. So you can use any of this, okay, LiAlH4, okay, or okay, you can use, okay, just give only one, okay, no need to mention both, okay. So you can say or, okay, if you don't want to write down that, so you write down NaBH4. Now they ask you to identify suitable region, okay. Sometime, okay, they even add, okay, identify suitable region and condition, but that doesn't mean that they are going to give you 2 marks. Okay, in this case they didn't mention, okay, in this case they didn't mention, okay. One of the reason, most probably they don't mention, maybe students might miss out, okay, especially for the NaBH4. So maybe I think they decided not to ask about the condition, okay. But the condition, if they ask for condition, okay, in dry ether, okay, in dry ether, and this one is going to be aqueous condition, aqueous, and then it is going to be room temperature, and I think this one is also room temperature. Okay, again, nothing will change over here. Okay, now identify a suitable region, okay, for step number 2. Now step number 2, this one is the, in the beginning when we learn about hydrocarbons, okay, we even in AS we have learned about this, okay. If you check your textbook, okay, there are few things that they mention, even in the textbook they mention about this Al2O3, okay. They mention about this, this is going to be, you are using this, okay, and then you can change it into alkene. Now in the same textbook, on the same page, you can see there is a question over there that they also included over there, where you need to know, apart from using Al2O3, you can also use concentrated H2SO4 to achieve this, or you can also use, okay, sorry guys, I got disconnected, okay, but anyway, let me repeat again. So you need to know, okay, whenever you do this, okay, it's either you need to use concentrated sulfuric acid, you can use concentrated phosphoric acid, okay, or you can use the Al2O3. Okay, let me just double check for you, the, do you need to heat them up, okay, give me a second. This one, if you want to check, it's going to be in page 230. Okay, so this is going to be dehydration. Okay, the catalyst that is going to be used is going to be Al2O3 catalyst. And it is going to be, the reaction is going to take place when alcohol vapor is passed over hot catalyst. Okay, so passed over hot catalyst. So if you want to mention it's going to be passed over hot catalyst of Al2O3, it's possible. Okay, but again in the same page, okay, there is a question over there, okay, which is question number 6. Over there only you will see you can use, okay, we can use sulfuric acid and phosphoric acid to catalyze. Okay, but do remember they mentioned about the temperature also. Okay, the exact temperature they mention about 170 degrees Celsius. So please remember this. So it must be heated. Okay, it must be heated. So there is a question over here. Okay, let me see. Okay, yes, 180 degrees heat, sir. Yeah, correct. So this one is going to be heated. Okay, 170 degrees Celsius. Okay, and then for the prelims, okay, do we get marked if we write CONC instead of concentrated and RTP instead of room temperature? Now, when I see here, okay, when I see the marking key, they only write CONC. Okay, there is no instruction, okay, to deduct marks. Okay, but for me, don't take any risk. Okay, write full. Okay, write in full. RTP, in the past also I never seen any questions, okay, where any marking key saying that deduct mark when RTP is mentioned. So to answer your question, possible, okay, possible, but I will not encourage you, okay, to do that. Okay, so this will be my answer for this. Okay, so concentrated, write in full. Even when I try to teach you also, I try to write it in full also. But again, it's relative. Like even for aqueous, I tend to put EQ. Still okay. It depends on your time. Okay, it depends on your time. If you're really rushing for time, then you put CO and C and so on. If you have time, come back. Okay, come back and then write in full. Okay, this is my suggestion. Yeah. So here, okay, heated. Okay, not 180. Okay, the one that I saw from the textbook is 170, and yeah, 170. And for this one they just put hot, okay, in the textbook. Okay, so maybe, okay, if you have seen any like for example any other marking key or something, yeah, you can also use that information. But here, since they didn't ask you the condition, okay, we still put the region only. Yeah, so again, this is 1 mark. It can be still 1 mark, okay, but we can still ask you about the condition. Most probably the decision why they only asked the region, why they didn't ask the condition, means most probably because sometimes the students, when we give this 1 mark, we say N. Okay, it means sometimes students will identify region correctly, but the condition they are wrong and they are not going to be able to get that 1 mark. So to help students, sometimes, okay, the people who prepare the test paper, they will suggest, okay, let's only test the region. Okay, let's not test the condition, but the mark they maintain. Okay, this is a situation. But sometimes, okay, they feel that they need to really test the condition. Then they will test the condition. In this case, the condition is not going to be is not given importance for now for this particular question. Yeah. Now, state the number of peaks, okay, of carbon-13 NMR spectrum of phenyl-ethene. Now, phenyl-ethene, okay, this is phenyl-ethene. Let me erase this. Now you can see here, okay, how many different carbon environment, okay, that we have over here. So I have, this is going to be one carbon environment. This is going to be another carbon environment. Okay, the carbon is attached to hydrogen and benzene group. And then I have another carbon environment here. Okay, and then you can apply the symmetrical rule. Okay, This is going to be another carbon environment, which is the same as this carbon environment. This is going to be another carbon environment, which is going to be the same as this carbon environment. And this is going to be another carbon environment. So in total, okay, we have total of 6 carbon environments. And you can see now, okay, roughly when you do, I think 3 papers already, this is the third submission. So 3 papers, okay, you can see when I go through also with you, they always try to assess you on this, and 1 mark, okay, and another 2 mark, okay, related to this. So it's always like that. They are not going to ask you a lot, okay, they are not going to ask you a lot, but they will be definitely asking about this, okay. Now, so suggest the carbon 13 chemical shift uh, ranges expected. Can you guys still hear me? Victoria, can you hear me? Okay.
You were lagging, sir.
Yeah, okay. I can see you all moving now. So anyway, okay, I think this one is okay, yeah. So I was actually mentioning about, um, please remember the chemical analytics part, okay, they will not give you a lot of marks, okay. So here you see it's they ask you, and then suddenly they came into analytics parts, and they just ask you about 3 marks question, yeah. So it's quite easy, okay. But again, okay, suggest, okay, they say here 2 marks question, suggest the carbon 13 chemical shift ranges expected for different types of carbon environment in phenylethanol. Okay, so I took the phenylethanol and I put it over here. Okay, so here I have a few carbon environments. Okay, what are the carbon environments? Okay, maybe this one. I also have this carbon environment, so maybe I can mention about that. And I can also see maybe this carbon environment or any of this carbon environment I can mention about that. Okay, so the carbon environment in benzene. Okay, so let's look at the in your period in your data booklet. Okay, what are the things that I'm going to look for? Okay, maybe the first one that I'm going to look for is going to be the carbon. Okay, this one. If I put it as number 1, the carbon which is next to carbonyl group. Okay, so this is going to be carbon next to carbonyl group. Okay, so I am going to expect, if I put for 1, I'm going to expect there is going to be a shift from 25 to 50. Okay, I'm looking for that. Okay, there will be a shift for 25 to 50. Why is that? Okay, so for what? Okay, for what? So that is going to be, okay, let me share the screen again, yeah. So maybe, okay. So when you look over here, okay, we can see the first one is going to be the 25 to 50. That is going to explain about the carbon that is attached next to carbonyl group. Okay, next to carbonyl group. I am also going to see the carbon that is directly attached to the carbonyl group. So let's look at here. This is directly attached to the carbonyl group. So we are looking at 190 to 220. This one. 190 to 220 directly attached to carbonyl group. Okay, so another one more that I can select, maybe something related to this benzene. So look for benzene. So not this one. Okay, not this one. So something related to benzene. So this one. Okay, you see, it is going to be carbon. Okay, carbon that might be attached directly is either carbon double bonds or in arene. Okay, so this might be one of it. So 110 to 160. So this one, if I put here any of this, okay, they will have that range. Okay, that is going to be 3. So this one is going to be 110 to 160. So this one you can say arenes, carbon in arenes. So here they say suggest. Okay, when they ask you to suggest, please suggest with reason. Okay, cannot simply suggest. Yeah, so please suggest the range and tell what is the reason. Okay, when they say here, okay, when they say chemical shift ranges for different types, okay, if possible, okay, they didn't say all, okay, but if possible, if they say something like this, at least, okay, 2 ranges must be given. Okay, so here, even in the marking key, you can see if you mention any 2 of here with they didn't even give you marks for reason. Okay, they didn't give you marks for reason, but I'm suggesting you to write down the reason. Okay, but here, as long you just give the correct range, okay, at least 2, then they will give you the full 2 marks. Okay, so this one you can get it, okay, from your data booklet, but make sure you select the right one. Okay, this is going to be carbon 13 NMR. There is also the proton NMR. So please be very careful which one do you select. Yep. Now next, okay, silver sulfide, okay, is going to be very soluble in water. Write very insoluble in water. Okay, so write an expression for the solubility product of Ag2S. So this one is Ag2S solid. Okay, they're supposed to give you 2Ag plus aqueous plus S2 minus aqueous. Okay, very insoluble in water. So write down the expression of solubility product. Now for solubility product, we only write down, okay, the expression for this and this. We do not write down for the solid Ag2S, okay, because the concentration is constant. So we write down Ag plus and then to the power of 2 and then S2 minus. So this is going to be the expression, okay, that they are looking for. And then they are asking the solubility, okay, is going to be 1.16 times 10 to the power of negative 17. So that is solubility, okay. So what is solubility? It means that let's say if you dissolve, okay, if let's say the reaction is happening, if this one we take it as X, okay, if this one we take it as X, this is going to be solubility means, okay, this one will minus X. Okay, when you add water, this one will be the number of moles, so it's going to be minus with X. And then here, you are going to have something like plus 2X. Okay, plus 2X. Okay, I hope you can see. So plus 2X. Okay, my internet is laggy again. Okay, let's wait for a while. Jason, can you hear me now?
Yes.
Okay, so let me continue again. So talking about solubility, okay, so I will take solubility as X, okay. So we take it as minus X. So this one will be plus 2X and this one will be plus X. Okay, that is going to be happen if let's say they dissolve like normal. So they actually have 1 mole, 2 moles and 1 mole. Okay, so just like that. So here, if I want to calculate the numerical value of the solubility product, okay, so the KSP, okay, is supposed to be silver ion, okay, the concentration of the silver ion, okay, the silver ion is going to be 2x. So I put over there 2x, and then to the power of 2, and then here x. So it is very important, yeah, please take note of this, okay. 2 to the power of 2 is going to be 4, so x to the power of 2, then x to the power of 3, okay, and that's going to be your KSP. So 4 times 1.16 times 10 to the power of negative 17 to the power of 3. And you will get the answer. Okay, so let me calculate also. You guys also calculate. Okay, when I saw that number, I was thinking I'm wrong. Okay, but again, just double check. Okay, just double check, and you will get, okay, 6.24 times 10 to the power of negative 51. Okay, so here they didn't say how many significant figures. Okay, so 3 significant figures must be there if it is not mentioned. Yeah. So here, okay, KSP is 6.24 times 10 negative 51. They want only the numerical value. Sometimes they will ask you to find the unit. If they ask you to find the unit, then you'll have another one more mark for it. Okay, so here is just a numerical value. Okay, doesn't matter. Now calculate the minimum volume of water needed to dissolve 1 gram, okay, of this solid under standard condition. So what you need to do is to find the number of moles, okay, number of moles of this. So the number of moles is going to be 1 divided by, you calculate, okay, using the MR, okay, the MR is going to be 247.9. And you will get 0.00403 moles. Okay, so now, okay, using this number of moles, I need to calculate, okay, I need to calculate the minimum volume required, okay, to dissolve this. Now, if you want to dissolve this, okay, so we are trying to look into not the KSP, we are looking into the solubility. Okay, we have to use the solubility data. Now, the solubility data is going to be 1.16. Okay, times 10 to the power negative 17. Okay, so what I need is, okay, I need this 1.16 times 10 negative 17 equals to, okay, number of moles. Okay, so the number of moles is going to be 0.00403 divided by the volume that you need. Okay, so you just need to put it over here and then use the solubility. So V is going to be 0.00403 divided by this, and you will get the answer in dm cube. Okay, this one, if you do, you will get 3.5 times 10 to the power of 14. Okay, dm cube. So they didn't tell what is going to be the significant figures, but the data that I have over here is in 2 significant figures. Okay, but if you have 3 significant figures, then please include So here I will write down 3.5 times 10 negative 10 to the power of 14. The important thing is I am going to use solubility. Okay, I'm going to use solubility. So the data here, then you will calculate the volume. Now next, okay, this is going to be bromic 1 acid. It's a weak acid. So if it is weak acid, write down the equation HOBr. They are going to give you H plus and then OBr minus. Okay, so the Ka is given, and then you need to calculate the pH. Okay, so if you have that, okay, I think the best way is to write down what is Ka. Ka equals to H plus times OBr minus divided by concentration of HOBr. There are few assumptions that is going to be taken. One is, okay, we assume that the amount of moles that dissolve for HOBr is too little, so we take the initial concentration, okay, and we also assume, okay, the concentration of this and this are the same because number of moles 1 and 1. Okay, so here I can just write down H plus OBr minus is also H plus. I put like that, and I have, okay, use the assumption, okay, this one HOBr, and I have the Ka. So just apply the same formula. So 2 times 10 negative 9 equals to concentration of H plus to the power of 2, and then concentration of HOBr, which is given 0.2. So just find out what is H plus. 0.2 times 2 times 10 negative 9 square root 2 times 10 negative 5. pH is going to be negative log concentration H plus, which is going to be negative log you will get the answer as 4.69, so 4.70. Next is going to be, okay, you are going to have something like a buffer solution. Okay, so you have potassium hydroxide, and then you are adding to HOBr. So we need to calculate the pH of the buffer solution, okay, that is going to be produced. So here, okay, the way to do this, okay, is going to be first, okay, I think better if you want to write down, okay, if you're looking for the pH, okay, first find out what is going to be your number of moles of KOH. Okay, number of moles of KOH is going to be 5 times 0.2 divided by 1000, and you will get 1 times 10 negative 3 moles. So when I have potassium hydroxide, so potassium hydroxide, they give you K plus and OH minus. HOBr gives me H plus and OBr minus. So what happens here is my OH minus, okay, they will react, okay, with my H plus. Okay, they will react with my H plus. So you need to first calculate first what is going to be your initial HOBr. So I'll just make it bigger, HOBr. to give me H plus and OBR minus. Okay, so initial HOBR, okay, you can see here the data given. So 20, so you can calculate N of HOBR, and this is initial. So this is going to be 20 times, okay, 0.2 divided by 1000, and that's going to be 4 times 10 times -3. That's going to be your initial. Okay, so if you follow ICE, so initial, okay, initially is going to be 4 times 10 -3. Initially there was 0, it was 0. Now after that, okay, after that, at equilibrium, okay, at equilibrium, you are going to have, okay, you are going to have how much HOBR. Okay, so the HOBR, they are going to react, okay, the KOH, okay, going to react with HOBR, okay, to give you, okay, if I erase this part, KBR, KBR, H2O, I think KOBR. Okay, you are going to get KOBR plus H2O. So it means one mole reacting with one mole. Okay, so here, when I have 1 times 10 -3, okay, they are going to react, okay, with 1 times 10 -3 here, okay, to give you this. So it means the HOBR is going to decrease. Okay, it's going to decrease because they are going to react with KOH. So here, okay, my if you look at equilibrium, okay, the changes that is happening over here is you are going to, okay, react with 1 times 10 -3, okay, which is going to be, you are going to get 3 times 10 -3. So, or you can say number of moles of HOBR at equilibrium is, okay, 4 times 10 -3 minus 1 times 10 -3. You are going to get 3 times 10 -3. That's going to be at equilibrium. Now, we need to also find out what is going to be the number of moles of BRO minus, okay, which is this one, at equilibrium. Okay, and this one is quite simple. Okay, so this one, they are going to give you, okay, this one is based on, okay, the KOBR that we have. Okay, the KOBR that we have. The KOBR, okay, if you can ask me why it's not coming directly from here. Okay, why it's not coming directly over here. We don't need to even use the ice over here, because for buffer, okay, for buffer, even though we know that, okay, they will dissolve to give you this and this, okay, but the amount that you are getting for this is too little. Okay, too little. So most of the OBR minus is coming, okay, from here. Okay, it's coming from here. So again, yeah, Lavi, you can go. So here it's going to be 1 times 10 -3. So KOBR supposed to give you K plus and OBR minus. So if you have 1 times 10 -3 complete, they will give you 1 times 10 -3, 1 times 10 -3 also here. So the number of moles of OBR minus at equilibrium will be the same. We are not including this. Okay, we are not including this. So it's going to be 1 times 10 -3. Okay, once we have that, okay, so we just need to find out, okay, what is going to be the H plus. Okay, so the H plus, okay, is going to be, we will look at the ratio. Okay, the ratio that you have over here is going to be 1 over 3. Okay, if you look at OBR minus divided by HOBR, that's going to be 1 over 3. Okay, so this one, okay, you can use the formula, okay, the buffer formula pH. Okay, if you want to use the pKa plus log salt divided by acid. Okay, if you want to use that, okay, you can continue using that. Okay, but if you want to use this method also, the one that is mentioned in the marking key, okay, 1 over 3, and then they calculate the H plus separately. Okay, that one is also possible. So whatever way that you use, okay, you will get, okay, so pKa that I'm going to use is going to be the pKa that I have. Okay, use the Ka over here. Okay, you can calculate the concentration of salt and acid. You can see this is the salt, this is the acid. So you can use log 1 over 3. Okay, pKa is going to be negative log 2 times 10 negative 9. And then you get. Okay, let me check the answer. Eight point 69897. Okay, so if you calculate this, okay, you will get 8.9. Okay, can you check whether you get 8.22? I'm not getting the 8.22. The ratio is 1 over 3. H plus is 3 times 2 times. Okay, so if you are getting that, then it's fine. Yeah. So you are going to get, okay, the value. Okay, please check on the calculation again. Okay, so you are going to get, as long you mention, okay, here the correct answer, okay, is going to give you 2 marks. Okay, so the working is important. Okay, please remember they don't bother what kind of working that you are using. Okay, but the one that they have highlighted is you need to state these 2 working. Okay, whatever working that you do, as long you mention about this, then you can have that 1 mark. Okay, so this is going to be important also. Okay, please take note of that. Okay, so please use. Okay, but again, here they find the ratio. Okay, find the H plus, then they calculated the pH. Okay, so please you see also. Okay, what which of the ways that you can use so that, okay, you can get the right answer. Okay, now for number 6. Okay, let's try number 6. Now, the elements in group 2, okay, include magnesium, calcium, strontium, and barium. Write an equation, okay, for the change representing the first ionization energy of magnesium. Include state symbols, okay. So magnesium, okay, make sure it is in gas, okay. This is very important. Okay, so it will give you Mg plus, okay, and then it is also going to be in gas, and then plus electron. Okay, if you do not mention, even I don't think so, they need to say include state symbols. If they don't mention also, if you do not write the gas, you will not get the 1 mark. Okay, write an equation for the reaction with strontium and cold water. Okay, strontium do react with cold water, so strontium, okay, um, if you are not sure, okay, you know, like magnesium, okay, magnesium reaction with water, I think there's 2, yeah. So you can have either MgO or MgOH. Okay, please read on this, because the reaction is going to be different. One is going to be H2O, okay, and then another H2O. Magnesium is special a bit, okay, because um, as you go down the group, okay, the reaction is going to be more vigorous, more reactive. So the one on top is not so reactive. So with water, okay, they can give you MgOH 2 plus hydrogen gas, okay. But if you happen to increase the condition or make the condition more extreme, if you heat up or you put a reaction with steam, okay, so the reaction is going to be different. You are going to get MgO plus H2. That's the difference. But the rest of them, okay, the rest of them, they will follow, no need to have like, they will follow the normal condition, which is going to be the hydroxide. They will follow the hydroxide. So it means that strontium, okay, when you react with water, okay, they are going to give you strontium hydroxide plus hydrogen gas. Okay, this is going to be the equation. Since they mentioned about state symbols, okay, so you need to write the state. So this is going to be solid, and this is going to be aqueous, liquid, yeah. Okay, it's going to be liquid. Okay, liquid, and then this is going to be aqueous, and this is going to be gas. So the only thing that you need to do is to balance the equation. Okay, you balance the equation by putting 2 there. Not balanced also, you will not get them up. Okay, please take note. Describe and explain the trend in reactivity observed in reactions of these group 2 metals with cold water. Now, this is what I mentioned just now. As you go down, okay, please remember the size is going to increase. When the size is increasing, okay, if you look at the electron also, the ionization energy is going to become lower. Why? Because it's easier, okay, to release the electron, okay, because they are further away from the nucleus. Okay, the electron, the whatever electrons, okay, they are further away from the nucleus. Okay, so less attraction. So in group 2, okay, we are talking about metals ability to lose electron. So we look at into ability to lose electron. So the reactivity, describe reactivity will increase. Okay, reactivity will increases down the group. Okay, and then you need to mention about, okay, because it's 1 mark, okay, and then they also ask you to explain. Okay, so you need to explain, and okay, why. Okay, so you need to tell, okay, it is easier, okay, it's easier for the electrons to go out. Now, since they already mentioned about ionization energy, I think the best way is to relate with the ionization energy. Okay, so you can say it is easier. Okay, it is easier, or you can mention about the ionization energy. Okay, it's easier to ionize down the group. Or you are not sure, okay, you want to use the ionization energy. Okay, instead of writing and it's easier to ionize down the group, you can say and the ionization energy okay, ionization energy decreases down the group. Since it's only 1 mark, okay, so you can leave it like this, but normally I will include Y, okay, because, okay, it's further away, okay, further away and shielded more, okay, from its nucleus. Okay, this is normally when I will write if it is 2 marks. Okay, if it is 2 marks given. Now, group 2 metal nitrates decompose when heated. Okay, so this will be the last question over here. So, nitrates decompose when heated. Do remember, carbonates also decompose when heated. So, describe fully what is seen. Okay, so you see nitrate, any kind of nitrate. Let's say I take one example, calcium nitrate. Calcium nitrate, when you decompose, you are going to get calcium oxide plus NO2 plus oxygen. Please remember, there's only limited reaction that generates oxygen directly. And one of the reaction is going to be the decomposition of nitrates. Okay, so they do give you all this, okay, but no need to balance. This is just to show you, okay, but again, this is colorless, okay, this is going to be solid, okay, a white solid. Generally group 2 oxides are going to be white, okay, so here this is going to be a brown gas, brown acidic gas. So here they are asking describe what is seen, okay, so there are two things that you can see. So you just write down the both things that you can see. Okay, so brown gas, okay, brown gas, N. Okay, if you don't mention N, okay, you will not get the 1 mark. Okay, the brown gas and white solid. Okay, must mention white. Why? They want to test you, okay, about the group 2 oxides. Okay, they want you to know about that group 2 oxide. They are always white. Okay, now write an equation for the decomposition of calcium nitrate. Okay, so now they ask you to write, so just write down. So if they ask you to write down, then make sure, okay, you write down the state and also try to balance. So here, okay, you need to balance. Okay, so I just put 2, I put 4. Okay, so if I balance this, I'm going to put 2 here. So nitrates are aqueous. This is solid, this is gas, this is gas. But if you look at the marking key, they didn't emphasize on the state. Okay, if you have time, please do. Okay, please do include all that. Now, describe and explain the variation in thermal stability, okay, of the nitrates down the group. Now, this one, okay, please remember, yeah, okay, please remember, this is not AS question. Okay, so if they ask you about this question in AS, they will give you only 1 mark. Okay, and you need to know, okay, why thermal stability generally for carbonates and nitrates, okay, it is going to be more stable. Okay, so thermal stability increases, okay, down the group. Okay, so 1, thermal stability increases down the group. This one you need to know whether it's in AS or A2. Okay, so this one must know. Then in your what is differentiating U, okay, and the AS is going to be the explanation. You must mention about that, okay, because now nitrates, okay, the size of nitrate is quite big, okay, so it's nitrate. So if I have magnesium nitrate, it's a small cation, okay. So if I have a bigger cation, okay, and then something like this, okay, when I go down the group, okay, what I can see, okay, I can see the cationic radius, okay, or the ionic radius, okay, increases, okay, or to be say, it's better because I'm not talking about anion, so I say the radius of cation, radius of metal cation or group 2 cation increases. And then if you look at the charge, okay, the charge are the same. Okay, so when the same number of charge is divided with the bigger radius, bigger volume, the charge density is going to be, okay, the charge density is going to decrease down the group. When this charge density is going to be decreasing, so this one you need to talk about ability of polarizing, or the polarizing power. Okay, so you can see that, okay, as you go down, less polarization from the cations down the group. So if you have less polarization, this NO3, okay, they are not going to be distorted. Okay, so the NO3 minus is less distorted. Okay, therefore the bond remains strong and difficult to be broken. So therefore, okay, you require more temperature to break them. Okay, so this explain about, okay, the thermal stability. So here, what are the things that you must write? Okay, thermal stability increases. Okay, you need to mention about any of these two, radius or charge density. Okay, so let's say I'm focused on charge density. That's one mark. And then you need to mention about less polarization or less distorted. So anything that is, you mention either this or this, you will get the full 3 marks. So that, I think, please try to reflect when you write down your answer. Are you going to write down all this? Okay, charge density, are you going to talk about less polarization? Are you going to use this less distorted? Are you going to use these terms? Okay, very, very important. Okay, please reflect on that. Okay, the last one, okay, explain about, okay, solubility of group 2 metal sulfates. This one is quite easy, you know. Why? Because even you don't know, okay, group 2, it ends with barium. Okay, barium sulfate, every chemistry student, they should know barium sulfate is a white solid. Okay, so you can see as you go down, okay, sulfates, okay, sulfates generally, the solubility decreases. Okay, so solubility decreases. So you just need to explain less soluble. Okay, solubility decreases. Now, this one, the solubility decreases. This one I told you, okay, it depends on lattice energy and also hydration, enthalpy of hydration. So you just say, okay, as you go down, okay, the size, because of the size, your both lattice energy and hydration, they decrease. Okay, decrease down the group. Okay, or less exothermic. But which one decreases more? Okay, this one I want to ask. Okay, it's already 10:10. Sorry guys. Okay, let me actually finish this. Yeah. So Charlton, which one do you think will decrease more? Hydration or lattice energy, Charlton?
Hydrated.
Yeah, please remember this. Okay, this one is going to be hydration decrease more than lattice. Yeah. Okay, your hydration, okay, hydration decrease more than your lattice, and this is going to be making, okay, it's going to be making the enthalpy of solution, okay, to become more endothermic or more positive, because the more positive it is, okay, it's going to be less soluble. Okay, so this is going to become more endothermic. And I think I told you to come up with these ways to remember. I do not know, I forgot already what I asked you to remember. Each, is it SHL, I think, if I'm not mistaken, SHL, sulfate. Okay, for sulfate, the hydration decrease more than lattice energy. For hydroxide, okay, for hydroxide, okay, the lattice energy decrease more. Okay, so please remember this, okay, SHL. Okay, SHL, okay, sulfate hydration decrease more than lattice energy. But if they are asking for hydroxide, okay, why hydroxide is different? Hydroxide solubility will increase. Okay, so hydroxide solubility will increase, so you just need to tell, okay, this one increase, this is also going to decrease. Okay, but your lattice energy will decrease more than hydration. Therefore, your enthalpy of solution will be less endothermic. Okay, so that is going to explain about hydroxide. So please remember these two. Okay,